Alright guys, today we're going to be adding on to ionic nomenclature. We're going to be adding something called polyatomic ions. Polyatomic ions are a group of atoms that are covalently bonded together, and the whole group of them has an overall charge. And so they're going to be in ionic bonds because they are ions. If you look at the back of your periodic table, you have a list of all of the polyatomic ions. You do not have to memorize these. You just have to know how to use them and find them on the back of your periodic table. So just to point out a few, and first of all, they're organized by their overall charge. Notice that there's literally only one that has a positive charge, and that's called ammonium. And so that's NH4, and the whole group that's covalently bonded together has a +1 charge. Some popular -1 charges is you'll see acetate. There's two ways you can write it. We will typically do the top version, that's most common, C2H3O2 with a -1 charge. Some other common ones are nitrite and nitrate. Notice there's just a subtle difference, ite and ate, and same thing, there's a subtle difference of 2 oxygens versus 3 oxygens. Hydroxide is a popular polyatomic. Something as common as you'll see kind of a string of things like hypochlorite, chlorite, chlorate, perchlorate. So all 4 of these had to do with chlorine, and it was just a changing of the oxygen count. So details, details, details. Pay attention to those. Some -2 common ones is sulfite, sulfate, carbonate. -3 phosphite and phosphate. So once again, ites and ates, and it's a difference of oxygens. So the naming of ionic compounds with polyatomics is going to stay similar to yesterday. So step 1, you always name the metal or the positively charged ion. Use Roman numerals if it's a multivalent. If it falls in the middle of that periodic table, remember I was calling it no man's land, that's where you use your Roman numerals. And then step 2, this is what looks different today, is you're going to name the polyatomic, name the group, and do not change the ending. So for example, we have NaNO2. Name the metal, sodium. Sodium is group 1, so it does not need Roman numerals, so we're going to say sodium. NO2 is the group, and if you look on the back of the periodic table, NO2 is nitrite. So this is sodium nitrite. The only exception is ammonium. Because it has that positive charge, it's going to be in the front. So if you have ammonium attached to a single nonmetal, you would change sulfur to sulfide. This is ammonium sulfide. But if you had 2 polyatomics together, you just name the 2 polyatomics. You do not change their ending. So this would be ammonium hydroxide. So a common mistake is to not recognize ammonium hydroxide as ionic. So there's no metal, which would typically be a covalent compound, but because these are 2 ions, you have a positive, a full positive, and a full negative, this is an ionic compound. So things containing ammonium, NH4+, not to be confused with ammonia, NH3. If you have an ammonium ion, it's an ionic bond. Okay, so let's practice naming them, and I hope you have a periodic table near you so you can decide Roman numeral or not Roman numeral when we name the metal. So for example, MgSO4. Mg on your periodic table is in group 2, so it does not need a Roman numeral, so this is magnesium. And then what's new today is you have a group SO4. So you'd look on the back of the periodic table, and SO4 is sulfate. So this is magnesium sulfate. Going to the side, we have CdClO3, 2, and we'll talk about why that 2 is there when we write the formula. Long story short, it came from cadmium's charge. So I just told you CD. CD is cadmium. And cadmium looks like it needs a Roman numeral, but it's in that 3-2-1 exception. We call it Katzenagel. Cadmium always has a +2 charge. So we don't have to use Roman numerals. It's just cadmium, and then we look up ClO3. Look at what's in the parentheses. Don't worry what's outside of the parentheses. And there's a lot of ClOs, so make sure you're picking the right one. And ClO3 is chlorate. So this is cadmium chlorate. Okay, let's look at FeCO3. So this does not have parentheses, but you can hopefully recognize a group. So Fe is iron, and something about iron is it is multivalent. It's in the middle of your periodic table, so we will need to figure out the charge of iron. So it's going to be iron something, and the group CO3 is carbonate. Okay, so if you remember from yesterday, how do we solve for a multivalent charge? We work backwards. We know the negative charge. So CO3, carbonate, carries a -2 charge, and there's only one carbonate. So we have a total of a -2. Therefore, to be neutral, iron must carry a +2. There's only one iron, so this iron is iron 2 carbonate. Let's do AlNO3, that's aluminum. NO3 is the group nitrate. Aluminum is also on that 3, 2, 1 diagonal within that D block, and so aluminum is always +3, no need for Roman numerals. Okay, two more. CuCN, we're going to recognize Cn is a polyatomic. Cu is copper. Copper is a transition metal, so it does have multiple valence charges, so we're going to give it Roman numerals. Cn, if you look it up, is cyanide. And the charge of cyanide is -1, and so there's only one of them. So to have this be balanced, copper must have been a +1 charge. And once again, people ask me, do I have to put a 1 if it's 1? Yes. You need to be really clear, this is copper 1 cyanide, not copper 2 cyanide. Okay, last one, we kind of have our exception. We have a group in the front. NH4 is called ammonium. And it looks like we have another group, SO3, is called sulfite. So this is ammonium sulfite. So the details in this unit really matter, so make sure you're writing with your clearest handwriting as possible. So now we're going to go opposite. So if we give you the name, you can then write a formula. So if you remember, ionic formulas have ions. We have charges that we're going to write next to each other. My pen has given out. And then we can crisscross the charges or figure out what you need for the charges to be balanced to 0. Make sure you rewrite without charges. And what's going to be different today is when you're dealing with these groups like SO3, and you might have 3 of them, you're going to have to use parentheses when you have multiple polyatomic ions. I think that will make more sense once we practice. But here is a good note. Do not reduce what's inside the parentheses. That is a set number. The number outside can change based on charges, but not what's inside the parentheses. So for example, if we wanted to write the formula for aluminum sulfate, they've already done some of the work for us. Aluminum has a +3 charge. Sulfate has an SO4 -2. +2 +3, we can swap down that number. We're going to need 2 aluminum ions, and we're going to need 3 sulfate ions for this to be balanced. So we'd have Al2, keep the parentheses, SO4, 3. And sometimes it helps just to like physically draw these ions out. We're saying we literally need 2 aluminum ions and 3 sulfate ions. So -2 + -2 + -2 equals -6. +3 +3 is +6. And so our charges balance to 0. All ionic compounds are neutral. So let's do some formula writing practice. So sodium arsenate. Sodium is Na with a +1 charge. Arsenate. So clues that you're going to have to use the back of the periodic table is you're going to see a lot of 8s and ites. There's very few ides, so that means that you might be like down here. That's just going to be chlorine. I'm jumping ahead. So sodium arsenate, if I go to the back, and it might take you a moment to search around, it looks like it's AsO4. And by habit, I just always put whatever's on the back of the periodic table, those polyatomics, in parentheses, just so I'm already ahead of the game. So I have a +1 charge and a -3. They do not equal 0. So one might be able to see that I'm going to need 3 total sodium ions to balance this one polyatomic. So my formula would be Na3ASO4. Notice I do not need parentheses because I only have one of that group. So the shortcut of that was just I could swap down the 3, swap down the 1, and get your formula. Okay, let's try chromium 2 hydroxide. Chromium is Cr. The Roman numeral refers to the transition metal's charge. Hydroxide, that is not hydrogen. This is on the back of your periodic table, and it's a -1 charge. It's OH with a -1. So we can see that our charges do not balance to 0. I can swap down the 2, swap down the 1. So I need 1 chromium ion, and I need 2 hydroxide ions to be balanced. Okay, let's try iron 3 phosphate. I'm just going to change up my colors. Iron is Fe. The Roman numeral, this time iron's being a +3. Acetate, you would look on the back. So that's a group. I'm going to just immediately put it in parentheses. C2H3O2. The whole thing has a -1 charge. My charges don't balance, so I'm going to swap and drop down the number. So 3 and 1. So I need 1 iron ion, and I'm going to need 3 acetate ions. So remember, our final formula, the numbers are low, there's subscripts, and there's no positive or negative because our charges are balanced. Barium perchlorate. So barium is Ba. Based on where it is on the periodic table, it's in group 2, so it has a +2 charge. Perchlorate, so it's going to involve chlorine and oxygen. Per means there's 4, and it has an overall -1 charge. So we're going to need 2 of those to balance our 1 barium ion. So we have BaClO4, close parentheses with a 2 on the outside. Okay, 2 more. Cobalt 1 bicarbonate. Capital C, little o, +1 charge. Bicarbonate. On the back of your periodic table, you also might see hydrogen carbonate. Those are synonymous to one another, so you could see either one. That's HCO3 with a -1 charge. Love when this happens. Our charge is already balanced, so you just need 1 of each. So I'm going to let go of the parentheses, and here is cobalt 1 bicarbonate. Okay, ammonium chloride. We know that ammonium is the only polyatomic with a +1 charge. Chloride, IDE, just indicates that it's a single element. So once we introduce polyatomics, y'all forget that it could also be from the front of your periodic table. And then in this case, our charge is already balanced to 0, and so you just need 1 of each ion, and you have NH4Cl. Okay, let's see if we can find the mistakes in the following formulas. So they were asked to write magnesium nitrate. Already know nitrate's -3. And then charge-wise, you would need parentheses around that polyatomic. So it should have been MgNO3 with parentheses and 2 on the outside. Manganese 4 sulfate. Ooh, tough. So +4, -2, you would have swapped and dropped to 2 and 4, but it's swap, drop, and reduce. So that would have been MnSO4 simplified to 2, so a ratio of 1 to 2. 1 manganese ion for every 2 sulfate ions. And then tin, 2 hydroxide. Well, tin is our most missed element, it seems like, which is SN. It's a sin to forget tin. Tin 2. Hydroxide's -1. Oh, I'm going to put -1 on the outside. A great example, hydroxide, for whatever reason, y'all forget to put parentheses around hydroxide. Okay, let's find the mistakes in the actual name. So we have AlNO3, that should be aluminum nitrate. Aluminum has a monovalent. Aluminum is always +3, so Roman numerals are unnecessary. Iron sulfite, I agree with. It's probably the charge. Sulfite has a -2 charge. Therefore, iron would have had to carry a +2 for this to be balanced. CDO, cadmium oxide, so first mistake, IDE. Cadmium is a monovalent set charge of +2, so it does not need Roman numerals, and 1 was wrong anyways. Okay, this is a recap. This is not in your notes, but it's nice just to see part 1 and part 2 of Ionic all put together. So we're going to write the formula for cadmium nitride, cadmium nitrite, and cadmium nitrate. So cadmium is in the middle of your periodic table, but it's in that diagonal stretch. I call it the 3, 2, 1 diagonal. And so cadmium always has a +2 charge. I'm just going to write them all down. So now it's just paying attention to the ending of the anion. So nitride just indicates an element. And based on where nitrogen is, it wants to gain 3 electrons. Nitrite is on the back of your periodic table. NO2, put in parentheses, -1. And nitrate is NO3, -1. And then just do your swap and drop. We're going to drop down the 3, drop down the 2. We need 3 cadmium ions and 2 nitrogen ions to be balanced. +1, -1, drop the 2, drop the 1. We have cadmium, 1 cadmium ion, and 2 nitrite ions. And then similar, but subtly different, cadmium, and we need 2 nitrate ions. All right, there is tons of practice in your packet for you to practice, and thanks for watching.